Hello everyone, welcome to Testing Embedded UIs, part of our Embedded UI Live series. My name is Thomas Fletcher, I'm Vice President of Crank Software. I am one of the co-founders here at Crank, and today we're going to be talking about the topic of testing as part of our live series. If you haven't subscribed to our live series to our YouTube channel, I encourage you to do that now. I'm also going to ask you if you have any questions during the session, things that come to mind. Don't wait till the end, just pump them right in. We will take the questions at the end. So let's get started. So today we're talking about embedded UI testing. And why are we talking about testing? It's a big topic because UI testing is a little bit different from your average test activity. It involves a lot of the same steps, but it has a lot of different challenges and things to think about. And so we're going to cover some of that today and sort of put that into your mind in terms of things you should be thinking about when you get into the process of testing your user interface. Your embedded user interface in particular offers new challenges, but we're going to cover that in another series of technical sessions where we talk about how you get your data onto and off of the target. So let's get started. So what is it about embedded UI testing that makes it interesting? Well, the first is the nature of what it is that we're testing. I'm just going to put up a little video here. It's going to kind of be running on the side. We're going to refer to that as we're going along. So one of the challenges with UI testing is that it's not your typical environment in terms of a procedural environment where I make a call, I get provide some input, and then I get a response. I can wait for it easily. It's a much more interactive, much more fluid environment. So what we want to do is we want to consider what it takes to execute a UI test program, and then we're going to think about what we need what assistance we need from our framework, and how we go about doing that. So the very first thing we're going to do here is we're going to talk about how do I actually pretend like I'm a user, right? Part of UI testing is driving a user interface. You can see here that there's some clicking going on, there's some sort of navigation. We're working our way through different screens and different modalities. So the very first thing is that we need a way to stimulate the user interface, right? We need to do some sort of injection of user events. And I'll use the term event pretty generically. It may not actually be a true event, but some way to either capture an event stream of user interaction or for us to be able to programmatically generate that event stream. Once I have the ability to stimulate the UI, then the next step is not just like a function call. I make the function call and I get the return value. User interfaces are a little bit more dynamic than that. They're a little bit more complicated. Oftentimes, that stimulation will take some time to propagate its way through the processing system of the user interface or the graphics package that you're working with. And so the next step is really important, right? We want to wait for our test point. And I'm going to highlight here that this is a test point because it's not necessarily that the minute that you inject event or that you stimulate the user interface with data that you're going to actually be working with a testable system. If you look at what's going on right now, we've got animations that are rolling through. We've got feedback from the UI to the user that's very dynamic. That's very, very difficult and very challenging to test because things are constantly moving. They're constantly in motion. So being able to wait for this test point is something that's really important. And it's something that you need to rely on your graphics framework like Storyboard, to be able to give you that go point, right? When this event occurs or when this situation occurs, now we can actually start doing our testing. Okay, so assuming that we've got this notion of waiting for a test point, what comes next? Finally, we're at the point where we can execute our tests, right? And what does it mean to execute the test? What does that mean in a code-centric world? Well, you'd be validating certain characteristics, whether it's the output from the function or some side effects. You'd be validating those environmental situations against your input, right? I triggered an input, I waited for a test point, and then at this test point, I expect a certain environment. I expect a certain model. I expect a certain presentation. So in the UI world, we can branch this execute test into kind of two different categories. The two different categories that we like to think about them as is there is the logic type of test, and then there is the display type of test. Two very different areas, and what we might also call this as, what am I testing when I'm testing the logic properties? I'm testing the properties of my scene. I'm testing whether or not a button was depressed or released, whether or not an object is in the right place, whether or not something is made visible or not, but I'm testing it at the property level, right? So I'm looking at my visual scene, and I'll use scene as kind of a generic term for all of the visual objects that are in your display, and you're looking at their properties, right? Their X, their Y, their position, their size, where they sit relative to one another. This is probably the closest, the closest relationship to standard functional testing, is that we're just comparing values. But the challenge is, in a user interface, we also have to consider the presentation. So I like to think about it as logic and display testing, as property testing and pixel testing. And so in this display scenario, what we're really doing is we're looking at how is the end result coming together, right? What is the presentation to the user? Because ultimately, we are an embedded UI, and that's what we want to be looking at testing. So it's not just about whether the logic of the operation corresponding to the, your input got executed, but whether the presentation actually, kind of worked out. So let's walk through a scenario. I'm going to turn the video off here, and let's walk through a scenario, and let's talk about how, how we'd address some of these challenges. So here is our scenario that we're going to be looking at. Our coffee application is running, the same one that we were sort of animating. We'd like to add a new functionality, and we'd like to build that up and test it. So what does that look like? So what I'm looking at here is when I select a size of my coffee drink, I'd like to give the user some feedback. I'd like to pop up a layer and talk about this is your selection, and kind of step you through that just as a bit of a soft confirmation, right? This is a workflow. If we were looking at logic testing, if we were just looking at logic testing, the scenario would be relatively clear. I'd like to push the button, that's my inject. I'd like to wait for the test point. I'd like to wait for the UI to kind of react to that. And when the UI is reacted to that, then I would like to validate that this pop-up is now visible, right? That the user is able to see it. So this is what that test point might actually result in. And here we can start seeing the difference between logic and display in terms of some of the challenges of UI testing. Everything I just said in my logic test was true. The pop-up is visible, but is it visible in the right way? No, it's not, because it's sitting in the wrong object stack when I compare it to the other objects in my visual scene. And so this is the challenge. So we can make some adjustments. We can compensate for that. We can put that into our logic scenario. No problem. We'll just test to say, is it visible and is it on top, right? So we can kind of extend our test case some more. And when I do that, now what I end up with is this scenario. Great, our tests are passing, but it's still not presenting the way we would like it to. Because really what we'd like is we'd like this bar not to be in the middle of the screen, but actually to cover up the select size, right, to kind of replace that statement. So now I need to add one more condition into this logic scenario. And you can see here how one simple test scenario starts really blooming and blossoming in terms of the number of criteria I need to put in when I'm doing logic testing. So ultimately, this is the scenario that we wanted to test. We wanted to make sure that it was visible, it was correctly positioned, and it was placed in a way that was relative to all the other content on the screen in a way that made sense. Now, if I think about how much effort went into that logic test, that could be pretty complicated because the scene could be very large. So the nature of the relationship with everything else could be very complicated. This is where we complement our logic testing with display testing. What I would want to do now is take a screenshot, right? Take a snapshot of the display and actually be able to validate the content that we're looking at and say, is this content actually reflective of the content that I'm desiring. And that is a bit of a simpler test and more complicated because we're just going to look at the final composition. We don't need to look at the entire scene. We can just look at the composition of the pixels on the display. So when I do that, now I can start talking about some of the challenges of display testing. So what's the difference between these two displays? They look visually identical. So from my perspective, looking at this as a visual test, they look identical. But if I were doing display testing, I have to think about the criteria that I'm using to actually measure differences. In fact, they aren't identical. The top one has an opaque bar, and the bottom one actually reflects the true desired behavior to have a little bit of transparency, a little bit of nuance, transparency on that feedback bar so you can sort of see the background. It's really hard to see in this dark scene, but rest assured, it's there. How do I know that? Well, if I were to look at this situation of capturing the display and then comparing the display against my desired outcome, so some sort of golden masters of what those displays would look like, here's what I would end up with. I would end up with a visual difference that shows me kind of this intersection, right, or this onion skinning of how this display and this display are different from one another at a pixel level. Now, this is one of the challenges, just like logic testing has its own challenges in terms of scope and how many properties you're going to be evaluating for a particular input change. We have the same challenge with display testing. With display testing, there's a lot of different rendering technologies, and in fact, what we were seeing here is 3 different presentations where the bottom 2 presentations were rendered by different types of technologies. The top one was an OpenGL technology, and the bottom was software rendering technology. Visually, they appear to be the same, but we can see that they are, in fact, different. So what does this difference mean in terms of how we can gauge? Clearly, we can't just say, are the pixels identical? Because you may have different testing environments. You may be doing testing at a desktop level and on your embedded product. You may have a variety of different products that are showing the same display but are using different processing technology to render that display. So this is a real challenge, right? Is how do I actually get the display content to show me sort of a pass-fail result the same way I get the testing with the logic, the properties, right? And so there's a variety of different techniques, and what I'm going to do is I'm going to switch over into a web browser here, which is giving you a little bit of insight. You're going to lose me for a second, but it's giving you a little bit of insight into what we do for this type of testing scenario inside of Storyboard. Inside of our product, we use both of these techniques, both logic testing and display testing, to ensure that we have a situation where all of our rendering technologies, depending on the operating system or the CPU, the GPU, that they're all comparable. They are all giving you the same type of result. And so here you can see the variety of different platforms that we're executing what we call screen dumps. It's our display capture test framework. And for each one of these platforms, we run a series of individual tests, and those individual tests look at various visual scenarios. When they look at those visual scenarios, they're evaluating them not just on a pixel by pixel basis, but they're actually using a few different metrics to evaluate the visual scene that's being presented. And so you see those here as our SSIM, which stands for structural similarity measurement, and then HIST, which is a histogram measurement. 2 different analysis, numerical analysis techniques that run over the image, both on our golden image as well as our new target image, and can compare the 2. And this is where, you know, some of the nuance comes in, is that you're not looking the same way as you're not looking at pixel by pixel comparison, because visually you can see that these 2 results here, visually to us, they look identical. And even if you zoomed right in, you'd have a really hard time seeing that there was a difference between them. But mathematically, you can see there is a difference. And the difference is caused because of floating point, small rounding differences that ultimately, in this case, are taking those gradient values and turning them into slightly different alpha values. And the difference might be a value of 1. It might be a difference between the value of 240 and 239, but it is a visual difference. And so to compensate for that difference between technologies, we can use the SSIM and the histo values as a benchmark and then put them into ranges, right? And this is the same sort of technique that you can use within your own user interfaces. So let's go back to our scene now. So now, kind of considering all of that together, you can see that UI testing can be very complicated. It can involve a lot of complexity. But what's important is that it's not really about taking one path or another. It's a matter of combining both techniques to your maximum advantage to be able to ensure that the areas of your product that you're looking to test can be validated both at a display level, in terms of what's being presented to the user, but also at a logic level. And for this, what you're looking for in terms of the entire support package from your graphics frameworks is you want to be able to inject events. You want to be able to ideally quickly record an interaction model and then play that interaction model back. We call that capture playback within the storyboard context, but being able to inject events as if you were a user, being able to look at the execution of that input and wait for a particular test point, and being able to do that at arm's length from the user interface. So can I wait for my data to be processed and wait for a certain situation to be reached within the user interface where it's stable for me to start executing some logic tests or snapshotting displays? And these are really kind of macro level operations. When we talked about the display technique, we're talking about capturing the pixels and then running some post-processing to compare against something. Just the same way our logic tests would be comparing against expected values. The difference here, our expected values are going to be another pixel display, right? Another image file that you're going to be comparing against. And then you can use different analysis techniques, the structural similarity, the histogram technique, in addition to the per pixel comparison, and use those techniques together to give you some sense of, are we passing or are we failing? So I'm going to take a quick look and see if we've got any questions. It's a good time to sort of jump out to our browser here and take a quick look and see what I've got. I do have a question from Electric Sheep. When it comes to testing, do you recommend automatic or manual testing process when it comes to testing embedded GUIs? So this is a great question. Ultimately, you will probably always have some aspect of manual testing. One of the challenges of the embedded environment is the nature of what you can automate and what you can't, and what resources you have available to you. Ideally, during a development phase, you're always looking to add automation, because frankly, testing the user interface is not a scalable activity if you're just simply clicking and moving and clicking and moving. There's no substitute for user testing, but if you have an event injection system that allows you to do capture, playback, play it back quickly, play it back slowly, you can model a lot of different user interactions as long as you've got the ability to wait for sensible test points to do that evaluation. If everything is time-based, it's really, really hard to kind of get the timing right because it's so fragile. And this fragility is ultimately one of the challenges of user interface testing in general. When we talk about user interfaces, they typically are very fluid. You're changing the visual content. The visual content, just changing color, is going to break your display testing. Potentially, you're changing the interaction model. Maybe I've got a button, and my button is not quite big enough. Maybe I sized it for thin thumbs and not my bigger thumb. That might break your logic testing because maybe you're looking at the size of an object's properties. And so this is one of the challenges, is staying on top of your test masters, your test results that you're comparing against, and being able to kind of draw that back and say, oh goodness, the UI is changing more rapidly than I can keep my tests up to date, right? That's a problem. But ultimately, automation is the way to go, and you want to look for a graphics framework that allows you to build on that automation. And there are a lot of commercial solutions out there of various sorts. A lot for the desktop environment, not quite as many for the embedded platform, but we're going to be covering that in some of our subsequent sessions. So hopefully this session kind of gave you a little bit of insight around embedded UI testing, some of the challenges involved, and some of the approaches that we can take. We'll go back to our video, and again, consider what's going on in this very, very simple application. Consider the richness of the user interface, consider the amount of movement and the ongoing animations and what you're using to draw people in. It's a significant challenge to test these user interfaces, and you need to understand everything that's available at your disposal in terms of tools to make that testing effective. Thank you very much for your time. We're going to be taking a little break for the next month or so and then picking things up again in September. If you don't want to miss out when we start up our sessions again, make sure you subscribe to the channel, and I look forward to talking to you in the fall.